Now this,
That'd be a big explosion.
this right here actually is where the rim of the thing is out here. And this is the central uplift. And this is 50 miles across from here to here. Or maybe a little less. So it's probably 120 miles around. So that'd be about a week-long canoe trip.
That would be interesting.
Speedboat? Yeah, but that's up in, that's in Ontario. No, it's in Quebec. It's in Quebec. Can you see this right here? Yeah, there it is, right there. Now it's, look at this. A probable, not a proven, but a probable.
That's pretty random.
Now that's called the Nazca Polka Arc. It's part of Hudson Bay, and actually, the lake there occupies. It's called a downfaulted graben. The central part rises up, and then outside that there's a ring section that drops down, and so that's now occupied by a lake. And now also look at this. This is almost certainly the. In fact, about a year ago, somebody actually came up with some evidence that this is Prince Edward Island. This is Nova Scotia right here. Nova Scotia is the island, right? Yeah, so this is Nova Scotia, and this is Prince Edward Island.
So what's the ratio between all three of those circles? It's almost like a line.
Well, since you asked. Oh, well, what this is, as it says, locations of known impact structures in North America. So this is the number that's now been identified.
What's the one that looks like in northern Alabama and Tennessee?
Wetumpka.
Where is that?
That's in northern Alabama, near Montgomery, Alabama. Not far from here. We could actually take a drive down there. Brad and I have been there. Jeremy, me and Brad and Jeremy went there.
What is it?
It's an impact crater. You know, down here in the Yucatan is the big one that was the dinosaur killer 65 million years ago. And as I recall, that was about how old this one is.
Probably the few above it.
I
might
think
be
it's
too.
closer to 80.
Maybe they've revised the date.
Yeah, we looked at that.
Yeah, we've visited, what, 10, 12 of these now? My goal is to go to every one in North America.
Does the energy feel different? I mean,
Does the what?
forget the science, but does the energy feel different like when you're standing on one? Or, I mean,
Oh, you know, I think if you lived on one, or if you were, hypersensitive, you might know it. But I mean, you can't ask me to forget the science because I'm a scientist. So you can't tell me to.
there are places you go
But you can measure. There are most definitely anomalies within the geomagnetic field associated with impact craters. Absolutely, and that's one of the ways that they use to identify them. So yeah, that's the current census. And you can see that's growing. Back in the 1930s, the only one that was known was this one. The majority of these have been discovered within the last 30 years.
on the west coast. The starburst.
Which one are we talking about?
Up in Canada, the starburst.
Notice the title here, Elizabeth. Locations of known impact structures. These are all of the confirmed impact structures, also called astroblemes, in North America.
Do you have a list of the states, each of the states where they
Yes.
do that?
Yes, I do.
That would be interesting.
Yeah, in fact, maybe somebody would like a handout listing all of these, because there's some very interesting possibilities here, and I was going to show you one thing. All right. Here is we'll call it the Prince Edward Island. Let's see, there's a name for that bay, and that should be the name of the crater. So there's Manicouagan right there. See, it stands out pretty. Here's the Bay of Fundy. That's right, isn't it, Sam?
Yep.
That's the Bay of Fundy right there. Yep. Gulf of St. Lawrence, that's what it is. The Gulf of St. Lawrence right here. Okay, let's see if we can locate. Here's the Nazca Polka Arc, and there's Manicouagan right there. Can you see it on the map? All right, now watch careful. There's the circle representing the proposed rim of this. This would be a very, very old crater, one this big, because a crater this big would have clearly have reset the ecological clock on a global scale.
How big exactly is that?
Well, it's hundreds of miles across, a couple of 100 miles in diameter.
Maybe 3 billion years old.
Probably, yeah, exactly. And likewise with this one down here, and let me see, there I'm superimposing a circle in that one, the Gulf of St. Lawrence crater and the Hudson Bay Nazca Polka Arc crater. And now I'm going to draw a line from the center of this one, proposed crater, to the center of that one. Now watch. Notice where it passes. Are you catching that? It passes dead through the center of Manicouagan. Now what's even more interesting is that there's the center of Manicouagan, and let's look at that line from here to here, and this point right there. So this is rather interesting, and this, to me, suggests the possibility of a very interesting mapping project when we start looking at the precise locations of these great cosmic events.
But they're different ages, right?
Oh yes, they're different ages. They would,
They're still golden mean. That's cool.
and they fall on a perfect alignment, center to center. It's almost as if somehow the existence of these two large ancient ones perhaps somehow governed where this one was destined to be.
If you had an extreme
The golden
anomaly
mean, the golden mean, the golden section. That's the call it the preeminent principle of sacred geometry.
Where's the hole in it?
If you had an extreme
If you had an extreme,
magnetic abnormality that would exist, let's say, for 50 to 100 million years on either one of those. On the third one that's coming in there, would that affect it?
see, I don't know. When it gets to like the scientific explanation for this, I would be at a loss. My first thing that I would do would be to set up a mapping project, which would be to begin, finding the locations and begin looking to see if there are patterns. And there are other patterns that I know of besides this one, but this one is a really elegant pattern and very elegant relationship, so that's the only one that I've included here so far, just as a suggestion of what might be possible to do. Now that we've got over 200 known impact sites around the Earth, we may be able to discover if there are patterns. We may be able to, by projecting those patterns, find possible locations of other impact structures that have not yet been discovered, particularly the ones on the bottom of the ocean, because, of the 200 and some that we know about, all but half a dozen of them are on the land. But the land is only a little bit more than a quarter of the Earth's surface area. So clearly there have been 3 times as many impacts into the oceans as there have been on the land. Now, of course, a smaller impact into the ocean may not leave a scar on the bottom. It will cause a gigantic tsunami if it's, more than a couple hundred feet in diameter, for sure. But, for it to leave a scar on the bottom of the ocean like the Burkle crater event did, it probably needs to be half a kilometer to a kilometer in diameter. But there are probably hundreds of impact sites that are on the bottom of the ocean that have not yet been found. And that's one of the things the Holocene Working Group is doing, is they're researching and looking for astroblems on the ocean bottom. But if it turned out that there was some type of pattern, and if you read the work of John Shaw, the geophysicist, he argues from the scientific standpoint that the locations of these craters are not random.
So you could do a lot of these with the red gleams on the America.
Well, that's what I'm suggesting. It would be an interesting exercise to begin looking for invisible patterns linking the sites of these impacts.
What are the dotted circles outside of
The dotted circle, well, the dotted circle shows that the original crater may have been that big. Based upon the way the bedrock is fractured and faulted, it's ring-like that extends out. It doesn't show up on the surface topography as much as this does, but it does show up, in the bedrock. And there are these faults, these circular faults that extend outwards, and that's likely, the result of the impact actually being bigger than what you see from the surface.
Almost how it was.
Ringed, yeah. Well, anybody who looks at the pattern of Atlantis and then looks at, multi-ringed impact structures can't help but say,
If you're sitting on a bedload of iridium and PMs or PMGs or whatever,
PGMs,
what does that do to the energy field of that space?
the platinum group metals, yeah, right, exactly. Okay, let's, look at this now. Here's the Clearwater. Now notice look at the left one. Now this was a tandem impact where you had two side by side. The one on the right up here did not leave multiple rings, or at least if they did, they're completely eroded. But the larger one, you can see the remnants of an inner ring. Now picture the Manicouagan. Basically, that circular lake of Manicouagan would have been occupying this zone. Because in a multi-ring structure, there are zones of uplift and down dropping. And so look at this at the form of this, Clearwater West, and then look at the Gulf of St. Lawrence. I mean, you see what I'm saying? There's the Gulf of St. Lawrence, and now look at Clearwater West. That could be Prince Edward Island, right? That's why, Gulf of St. Lawrence has all of the forms of being a remnant of a highly eroded impact structure.
The big one on top, too, a little bit. It's got a little remnant.
Right, you see, exactly. And why would there be so little remnant here? Well, because this area has been subjected to multiple glaciations that would have pretty much erased the topographic profile. Well, it certainly is possible that structures are going to show up in a linear fashion. I mean, that's actually to be expected and is confirmed now. I mean, look. You've seen this, but what are you looking at there? You're looking at 13 almost simultaneous strikes right there. If you count them, there's 13 of them.
It's like Shoemaker-Levy and
Yeah. I liken this, I always think of, I think of weapons when I look at these things, and I think, like the KT event, that was like getting blasted with a 45. The Eocene Oligocene, that was probably like getting blasted with a 38. This would be like a machine gun blast. Boom, 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 boom. Probably what happened 13,000 years ago was more like a shotgun blast. See, look at there. Linear impact structures, multiple. There they are. They're actually showing up all over the solar system. Some of them may be from broken comets, and others may be ejecta that's been thrown out of another bigger impact. But
that'd be like a rock slipping on the lake.
No, not really, because they're almost certainly produced by something like this, where you have a string of things coming in, because we've seen that. Now, we've seen that comets can break up and form multiple pieces that will arrive in a stream. And boom, 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 boom. One right after another. And that's what we saw with Shoemaker-Levy 9. That's what this picture is here, is a picture of Shoemaker-Levy 9. And if Jupiter had a solid surface, there would be a ring of impact craters around the planet. But it's a gaseous planet, so it didn't leave impact craters in the surface. Here's one. Back in 10 years ago, scientists discovered evidence that a series of comets smashed into Earth in just a few hours 214 million years ago, devastating animal and plant life. The impact left a straight line of enormous craters in the Earth's crust, according to research published in the science journal Nature. Experts say the impact would have plunged parts of the world into darkness for years, wiping out life forms. Notice the date on it? How old is the Manicouagan impact structure that we just looked at? 214 million years. Manicouagan is one of those aligned ancient impact scars. Geologists have tended to seek single giant impact structures as potential sources of catastrophe on Earth, but the temporal and spatial association of 5 impact structures described here indicates that the effects of synchronous multiple impact events produced by fragmented comets or asteroids should not be discounted. Now, look here is the United States, and look right there what's going across Kentucky, southern Illinois, Missouri, and into Kansas.
How would it be a straight line like the machine gun, that you showed a little earlier?
Well, picture. Now here's this line of stuff coming in, and the Earth is rotating and turning under it. The first one hits, the Earth is turned a little bit. The second one hits, the Earth is turned a little bit more. The third one hits.
Okay. Why was it so straight, I guess, on the other ones and a little bumpy on that?
Well, see, no, it all depends. If the stream is a young fragmentation and everything is lined up, but now if it's been out there in space, after a while, yeah, exactly. It's the debris is beginning to disperse. So
The atmosphere may deflect it a little bit.
exactly, yeah.
This may throw it just one way or the other, depending
So
on
the
its
ones
shape.
that don't have
On its shape, depending where it would hit.
Now you can see right across the central United States there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of these. They used to call them crypto explosion structures because they don't know what they were when they first discovered them, but they were all recognized as being geologically weird, right?
They're all craters?
Well, so far what has been proved, there's at least 4 of them have been proven to be craters. But the rest of them have not yet been proven because nobody's really gone and done the studies.
There it is.
Would that have anything to do with the New Madrid system?
I absolutely, well, see, now that's a good question.
One of them
Yes.
that's almost dead center on the New Madrid.
Right here, this is the New Madrid, and it's right in here by Cape Girardeau. Right in here is where the New Madrid system is. So yes, it's very possible that New Madrid, if these are all impact, which I suspect strongly they all are impact produced by one event, the New Madrid fault zone could be an ancient fault zone that goes all the way back to whenever this impact. And if I'm recalling, the dates on most of these structures is about 320 million years. And you see, I definitely think the New Madrid fault zone would have been reactivated by the glacial unloading and all the stresses being transferred through the crust. And the big earthquake of 1811 and 12, yeah, could be, still the crust of North America adjusting, post-glacial adjustment.
Well, there's 200 quakes a day right now on the New Madrid system, but they're anywhere from 0.01 to 0.1819, and you don't feel it until about
Right.
2.2. Is when you begin to feel it. 2.5 will rattle the windows and such as that. But there's about 200 quakes a day right now because I've got seismograph printouts on my computer.
So it's still
It's
Still,
moving.
yeah. So, okay, so here's yet another field trip to add to the list. Now that'd make a cool field trip. Go out there and visit every one of those structures. By the time you started in the east and got to the westernmost one, you'd probably have a pretty good sense.
Where is that southern Illinois? We didn't go to that. We were right there. But
We were right there and zipped right past it. Okay, there I've got them all named. So Furnace Creek, Crypto Explosion. So see, when I've got Crypto Explosion, that means it has not been proven yet to be impact produced. But it is recognized as being a circle of weirdness, a circle of geological weirdness. So the Jephthah Knob, Brad and I have been to that. In fact, I think it was me and Brad and Jeremy trip, we went to that one. But there's not a lot of surface expression that you can see clearly. We went to Versailles, been to both of those, but none of these out here. So, yeah, Woblo or Woblo, Astrobleem, so that's one of the proven structures. Decaturville Astrobleem, that's one of the proven ones. And it actually has a fairly prominent surface topography. Hazel Green, this one, they still call that an igneous intrusive, meaning that it has not yet been proven to be an astrobleem.
How do you prove it's an astrobleem?
Well, you find cosmic metal, for one thing. You find shocked quartz. You find shatter cones. There's a list. I've gone through this list, but there's a list of 6 or 8 different things that are always associated with high energy impacts. And if you find 3 or 4 or 5 of those things associated with a circular geological anomaly, it's a pretty good bet.
Yeah, if it's a billion years old, you're not going to find it because it's a bazillion years old.
Well, if it's a billion years old, you can still find, there'll be shattered rock going to depth, there'll be a circular, there'll be radial fault lines. There can still be a rare earth metal trace. There can be shocked quartz. If there's silica, a lot of silica or quartz rocks, the shocked quartz will last forever. Now, if it's a jillion years old, probably not.
All right.
This is interesting. Scientists have mapped enormous impact craters hidden under the Antarctic ice sheet. Look at the size of these. The space impacts created multiple craters over an area. Let's see. The craters may have either come from an asteroid between 5 and 11 kilometers across that broke up in the atmosphere, a swarm of comets or comet fragments. So were you aware of that there are these very large impact craters on the bottom of the Antarctic ice cap? Look at this. The scientists told a conference this week that the impacts occurred roughly 780,000 years ago during an ice age.
What is that Yellowstone?
Yeah, pretty close. Well, I was thinking.
That's Antarctica.
Yeah, but impacts of that magnitude can trigger effects anywhere on Earth because they send shock waves through the Earth that can, if you've got a zone of volcanic susceptibility or seismic weakness, I mean, the seismologists that have looked at the geophysical effects of the Yucatan impact, some of them have suggested that probably every fault line on Earth would fail. And there would be hundreds of earthquakes all over the whole Earth in response to that impact.
I don't think that's very far from the last pole reversal either.
I think you're right. Now when we look at this is Theophilus here. Look at here, the central uplift. So like when you go to Jephthah Knob, what is exposed on the surface now, the only thing that's exposed on the surface is a row of hills that's the eroded remnant of a central uplift. So a lot of the craters on Earth are highly eroded because it's the nature of Earth's atmosphere and plate tectonics and vegetation and everything, whereas on the moon they're almost preserved pristine. But when you study these and you look at them, you begin to look at the information that they reveal. Like here's a pair of craters, but clearly one of them is younger than the other one, right? Which one's the youngest? This one or this one? The lower left. How do you know?
Because it's laying
Right.
on top of the other.
Exactly. And when you look up here, notice here's a large crater, and there's a smaller crater inside it. There's another smaller crater. So you can set up a relative crater chronology that way, and this is going to be important when we go back to review some of the most recent research on the Carolina Bays that's come out in the last year or two. And most of the research coming in on the Carolina Bays is confirming that they were almost certainly a massive cosmic shotgun blast. But see, Carolina Bays have overlapping rims. I'm going to hurry through this because I don't want to spend time on what you've already seen. From Pawnee Hero Stories and Folktales that was published in 1881. In the beginning, before making people, Tirawa, the creator, decided to create giant creatures to live in this world. Tirawa made them in many shapes, but in several ways they were all alike. They were very big and very strong. So here we have, what do you think that this Pawnee story is referring to? The big mammoths, yes.
The ground sloths, the
Ground.
cave bears.
Yes, thank you, Whit. Thank you, Julie. Thank you, Sam. Dinosaurs were gone 65 million years ago, but they are big, but the Pawnee wouldn't have had stories about them. They would have had stories about woolly mammoths, though. Charles Darwin said this: "It is impossible to reflect on the state of the American continent without astonishment. Formerly, it must have swarmed with great monsters. Now we find mere pygmies compared with the antecedent allied races." And here's, I've shown you this, right? Have you seen this? No. No. Take a look at this. Now this, on the left, this goes way back to the probably early 1800s, before they had identified these creatures. On the left is the jaw of an elephant, modern African elephant. On the right is the jaw of a mastodon. And these mastodons were being found, their skeletal remains were being found all over the southeast, along the Ohio River. And they would find a jaw that would look like this, and they would compare it with a known elephant jaw, and they would look at the elephant's teeth, and they would look at these teeth. Let me look at that. Their first conclusion was this was a meat eater. This was a predator. And they were picturing a really huge, vicious monster. And they didn't know, here's the interesting thing. At the time of the Lewis and Clark expedition, it was not known whether mastodons were still alive or not. And I think I've mentioned how Thomas Jefferson sent sealed, secret instructions to Lewis and Clark on their eve of departure, telling them that if they encountered the incognitum, they called it the incognitum because nobody really knew what it was. If they found an incognitum, if possible, to capture it and bring it back. But needless to say, they didn't encounter a living one. But there's the skeleton of the great American incognitum. This one was unearthed in 1801 in the Hudson Valley. And we've seen this, so I'm not going to... No, they were not meat eaters. As it turns out, see, they eat tree branches. They're browsers. So they use these big teeth to crunch up the tree branches. That's how one of the main differences between mastodons and mammoths. Mammoths were grazers and liked to eat grass and stuff. Mastodons were browsers. That just shows you the scale of these things that were roaming around all over unglaciated North America. But I've got a few new ones in here I want to show you. These are the mastodons. And every one of these creatures went extinct around 12,000 years ago.
Which one is a mastodon?
They're both mastodons. Oh. Yeah. I thought he was going to say, who's that with the mastodon? Gilligan? I can tell we've got an old Gilligan fan here. Okay, Smilodon. Let's see. Yeah, here's my new Smilodon. Now, as you see these, you've got to bear in mind that when you get up in the morning and head out into your day-to-day activity, probably getting eaten by a large predator is not high on your list of concerns for the day. However, if you lived like 90% of the human race lived, coexisted, I started wondering, maybe it's the reason there was never a population explosion. Maybe there couldn't have been a population explosion when we cohabitated the world with things like that. And things like these guys, the dire wolves. Look at those guys. Now there's, you've got a 200-pound wolf bearing down on you, Brad. Now you see what the Pawnees were talking about, the giant creatures? Yeah, the giant Irish elk, they could have antler spans up to 12 feet. Yeah, and how in the world did they get through the forests? Now, can you imagine having a pack of dire wolves after you?
Yeah, but he could have used those things to flip them over their heads.
Yeah, but I'm not talking about now the Irish elk. I'm talking about Brad.
No, he's an appetizer.
And then the American Pleistocene lion, which was the size of a large horse. Let's see, I think I put a, yeah, that's how big, look how big that thing is.
A caveman.
How can you always tell a caveman? Well, because caveman always carries a club or a stick. That's pretty much how scientists identify.
Why do you look like the Grateful Dead guy?
The Grateful Dead guy.
Yeah.
Like the Geico
Man.
guy.
The Geico guy?
No. Yeah.
Oh, the caveman? Yeah. Yeah. Goodbye. And there's Mammothus trogontherii. This was I believe, the largest of all the mammoths, and they were up to 16 feet tall at the shoulder. They had one of these things on display about 10 years ago at the Fernbank Museum of Science. The damn thing was so big they had to take out the ceiling grid. I mean, he was huge. Did you see it? Yeah, you remember how big that thing was? He was just a little person. All right, now check this out. Here is the diagram of a modern grizzly skull, just for a size comparison. Then the Ursus spalaeus, the giant cave bear.
Oh.
And there are a comparison of a modern grizzly skeleton with that of Ursus spalaeus, the giant cave bear.
Prove that over there in Southeast Asia. There's a species of elephant over there now, which is about half the size
Yeah.
of a regular elephant.
Well, you know, they found on islands off of British Columbia and Alaska, right, they call them Pygmy Mammoths, and these were mammoths that survived the big catastrophe of 12,000 years ago, but they were half the size of their predecessors. And they were living in restricted domains, so they had restricted habitat, restricted food supply. They adapted to that by diminishing their body size. So again, how you basically, would identify a cave bear and distinguish a cave bear from a modern bear is that primarily not only their size, and this kind of gives you the comparison of Ursus spalaeus, the cave bear, but also the fact that they were usually, there's Charles R. Knight's painting. I love the work. He was like the first artist, 20s and 30s, that did prehistoric animals. So the cave bear generally, because of the fact that they're larger size, but also because they were usually found carrying or associated with clubs. So that was one way that you could typically identify a cave bear. Mammothus primigenius. Mammoth primigenius is the scientific term for the woolly mammoth. See, there were 4 kinds of mammoths, and they say this is the icon of the Ice Age. And of course, this was the most widespread of all the species of mammoths, found in Siberia, found in Alaska, found in Georgia, found in Central America. Mammothus imperator was about the size of Mammothus trogontherii, and they were huge. Elasmotherium sibericum, a giant woolly rhino, and this rhinoceros was as big as a modern-day elephant. And then, of course, Coelodonta, the woolly rhino. So there was 2 species of huge rhinos that went extinct. The Shasta ground sloth, the bison latifrons, the super bison. You can see how big that guy was. Some of the large horns on the larger specimens of bison latifrons have been up to 6 feet. Can you picture a bison horn up to 6 feet? And then there was Castoroides, the giant beaver. So that was the actual size of Castoroides. And Castoroides, as it says there, was very prevalent in the southeast. Now, modern beavers are known to have extraordinary ecological effects by building dams and ponds. I wonder what kind of dams they would have been building. Hoover Dam, yeah, Grand Coulee Dam of the beaver world, right, exactly. Oh yeah, and then there was Procoptodon, the man-eating kangaroo, the meat-eating kangaroo. Now this guy probably was extinct by 26,000 years ago, because you know the Australian extinctions were at least a half a cycle earlier than the 12,000 North American and Asian and European extinctions. Most of the forms, but I just put this in because this was one of the big. There were people living in Australia along with this guy, and then of course there was Arctodus. Now, this guy was considered to be the most formidable predator of the Ice Age. This guy was the top of the food chain. And you're right, and yeah, right. The zoologists and you know the biologists and so forth that have studied these guys have said that they were definitely built for high-speed chases. Their feet are shaped different than modern bears. Also, by looking at their teeth and the way their eyes are focused for long-distance chases. And with their long legs, and their teeth are definitely appropriate for being an exclusively meat-eating animal. And it said that based upon their skeletal structure, it's likely that they walked on two legs quite frequently. Now, I try to imagine having something like that living in the world with you. And imagine that thing coming in, and their reconstructions of it, that when it would attack a prey, it would oftentimes, as it was closing the distance and about to hone in on it, it would stand up on its hind legs, and when it would do that, it would just totally intimidate its prey right into submission. So it would do that to create a bigger. Can you imagine something like that coming at you on two legs? Without a 45. But see, I want you to just ponder what, what I'm trying to get here is how people just don't appreciate how different the Ice Age world would have been. And we could probably take any person in this room and drop them back into the late Pleistocene, and we probably wouldn't survive long. We would quickly be appetizers, yes. So it makes you really ponder what our ancestors, our predecessors, what kind of people they were, that they lived in this world and could actually survive in a world like this. And that's, when you begin to think about this is why how is it, that you begin to look at these gigantic animals and then to somehow blame their extinction on Paleo-Indian hunters. And to think that for half a century, that has been the dominant theory as to what happened to these. Now, if you say, well, okay, they hunted the woolly mammoths, but what about these guys? Well, then they'll say something like, well, Arctodus went extinct because humans hunted all the woolly mammoths to extinction, and therefore they didn't have prey anymore, so they went extinct. So somehow humans started the whole ball rolling by hunting the woolly mammoths. But the estimates are that there were 10 million or more woolly mammoths in North America. And the estimates are that there was, measured in only the tens of thousands of Clovis people that would have come across. So, I mean, it really, the notion that this 10,000 Paleo-Indians came and within 1,000 years ate every woolly mammoth in North America, that's what they want us to believe. And you've seen this guy here, Megatherium Americanum. And that guy,
Wow.
he was big. Yeah, he was huge. And he was kind of ugly. And he was probably ill-tempered. These guys, this was a variation of the Glyptodonts, and there were a number of Glyptodont species. And the Glyptodont species were basically related to the modern armadillos, except these guys, I don't know if I put a human in here for scale. No, I didn't. But those guys, you can figure they're 6 to 8 feet tall on their shells. So there were some pretty extraordinary animals. And you got to bear in mind that after the catastrophe, half of all the big animals on the planet, half the species were gone. Out of almost 300 species of animals over 100 pounds in body weight, almost half of them didn't come across the Pleistocene-Holocene transition. And here's another. I've thrown a few of the older, or not quite, the giant moa. He went extinct 800 years ago. Now, the giant moa is the one that's always blamed on the Maori. Because, you know, the anthropologists say, well, we see that the giant moa that lived in New Zealand disappeared 800 years ago, and there's a widespread charcoal layer that caps the strata-bearing giant moa. So therefore, it was the Maoris that arrived 800 years ago, did slash and burn agriculture over the whole island, and killed off the moas. And so the Maoris take the blame from official science for the disappearance of this creature. However, the Maoris themselves, that's not what they say. They say that there was a cosmic fire that burned off the island and almost decimated their ancestors and caused the extinction of the moa. That's their tradition. In fact, I have several recordings of their tradition, probably in this program right here. And this guy here was during the Miocene, and what's interesting in terms of animal life in the Miocene, birds were the top of the food chain in the Miocene. Birds were the baddest ass creatures on Earth during the Miocene. And this is an example, Phororhacos is an example of one of the large predatory birds. And he's about to make a morsel out of Brad's head.
13 million years ago? Or?
Yeah, this would have been like, 10 million to 20 million years ago. And this guy was just so cool I had to put him in. But humans did not coexist with this guy. So here, this is a scene that could be typical of the southeastern U.S. during the late Pleistocene. Woolly mammoths, you know, coming up on the watering hole, some saber-toothed tigers with their cubs.